Alright, let's take a look at some properties of logarithms. And right now we're going to start with the four that you see on screen here. And we'll talk about how they all work with each other. So let's start with property number 1. Logarithm base a of 1 is equal to 0. And again, that one's pretty simple to look at because again, if we want to walk through and take a look at our circle, anything raised to the 0 power is going to end up equaling 1. So that one makes a lot of sense. Pretty simple. Second property, anytime the base and the value in front here match each other, in this case base a of a, our solution is always going to be 1. And again, doing the circle, a raised to the first power gets me back a. So again, pretty much common sense with those two. So a couple situations that we could look at on there. Let's say we have log base 2 of 1. Well, that's going to be 0 because 2 to the 0 power equals 1. If I just have common log, that's also going to equal 0 because remember, common log. So log of 1 is the same as log base 10 of 1, and 10 raised to the 0 power equals 1. So again, a lot of common sense to be used there. So not a big deal. Second one over here, kind of the same situation. Let's go to the base 2 again, and let's do log base 2 of 2. So again, remember, we're asking ourselves 2 raised to what power equals 2? And that has to be the first power. If we go with a common log again, log base 10. So again, that's the same as 10. So 10 raised to what power equals 10? And that has to be a 1. So those two, pretty straightforward when you take a look at them. Alright, now this one, we have an exponent up top here, but we're also going kind of back to this situation right here, where we said that this a raised to the a, or base a of a, that logarithm was going to give us 1 as a solution. Well, if we look at this and go right back to doing the circle again, we're going to say, hey, a base a raised to the x equals what? And it equals a raised to the x. So let's put some numbers to this one and say, let's go with log base 2 of 2 to the 3rd power. So again, if I want to just go through and do the circle, I could say 2 raised to what power gets me this solution over here. Well, obviously 2 raised to the 3rd gets me 2 raised to the 3rd. But now if you want to look at the mathematics behind it here, log base 2 of 2 to the 3rd power, well, 2 to the 3rd power is 8, so we're saying find log base 2 of 8, and 2 raised to what power equals 8. And of course that's 2 to the 3rd. So that's another situation. So if the base and the value here match each other, whatever that exponent is our solution. So you can use a shortcut by doing the properties. Then we have one more here where we don't start with a logarithm, but we start with an exponent. And if you take a look here, the base here and the base here match each other, giving us the solution for the x value here. So we could have something like a, well, let's go with a number. So let's go with 2 with an exponent log base 2 of 3. And we want to see what that equals. So again, since this and this, the two bases match each other, that value on top is our solution. And then our fourth property here, if we have two of the same bases, log base a and log base a, and these two values are going to end up equaling each other. And this one's pretty much common sense. If the left side equals the right side and the two bases are the same, the parts that they're trying to find the solution to also must be the same. And we're going to take a look here at a couple of those situations. So one big part of number 4 is if we want to solve logarithmic equations. So let's take a look at solving logarithmic equations. Alright, let's go with one that's pretty simple. Let's go log base 3 of x equals log base 3 of 12. And again, not to insult your intelligence, but if you notice, what matches here, both of these have log base 3. Well, obviously, if the two sides of the equation are equal and they're both log base 3, that means this value and this value have to match. So we can jump right to x equals 12. It's the only way to make it work, as log base 3 of 12 equals log base 3 of 12. But this sets up our situational on why it works. Okay, so let's get one that's not quite as obvious, but still not terribly tough. So let's do this. Log of 2x plus 1 is equal to log of 3x. So this time we're looking at common logs. So if we kind of go back to that same concept we just looked at, this is a log base 10, this is a log base 10. If that's true that both of these sides of the equation are equal to each other, then these two parts must equal each other. So we just write 2x plus 1 equals 3x. And then we can subtract 2x from both sides. So we're just going to get 1 equals x. Now check to see if it works. 2 times 1 is 2, 2 plus 1 is 3. Over here, 3 times 1 is 3, so we get log of 3 equals log of 3. We know we've got the correct solution. Alright, let's go to one that's not quite as obvious as that. Let's go to the base 4 this time. Log base 4 of x squared minus 6, and set that equal to log base 4 of 10. Now, same concept, both of these are log base 4, so again, if both sides of the equation are going to equal each other, this part has to equal this part. So that's what we'll write out. X squared minus 6 equals 10. Now, since all we have are squares and constants here, let's get the squares on one side, everything else on the other. So we'll go plus 6 and plus 6. That cancels. We get x squared equals 16. And then we'll do square root plus or minus square root. And we're going to end up with x equals plus or minus 4. So again, let's check to see if this makes sense. If I put 4 here, 4 squared is 16. 16 minus 6 is 10. So I get log base 4 of 10 equals log base 4 of 10. If we put negative 4 in, negative 4 times negative 4 is 16. 16 minus 6 is 10. So again, we end up with log base 4 of 10 equals log base 4 of 10. So there's our two solutions for this problem. Now that's something that we want to be careful of. Eventually, remember we said we can't have a negative logarithm? Well, remember we did have a negative here, negative 4, but it wasn't a log of negative 4. It was negative 4 that was substituting in for x, which gave us a positive 10. And we can do the log of 10. So let's leave off with that.